Today we'll go over the matrix inverse. In general, when we say inverse, it's just, let's say you have A, so then the inverse will just be 1 over A, right? Together, A times 1 over A just gives you your 1, so this is your inverse. Similarly, in linear algebra, when you have a matrix, so if you have A, the inverse will be written as A minus 1. This is your inverse. And if you multiply A with A minus 1, it gives you I, which is your identity matrix. Like a 1 in diagonal and zeros everywhere. If we stick to linear algebra, what it does, it's that it undoes the transformation of A. So it is only invertible if it's a square matrix and if the determinant is not equal to 0. You can also use it to solve linear equations. So let's say you have matrix A times the vector x is equal to vector b. So x vector will be equal to the inverse matrix of A times vector b. So basically this is what you're trying to find. What are you looking for? This is your matrix A, and this is your answers. Now if you stick to a 2 by 2 matrix, which is a square matrix, so the formula for the inverse of it is 1 over A times D minus BC times the matrix. So D, A, minus B, and minus D. So as you can notice, this is your determinant. And since it's a denominator, if we want the inverse to exist, the determinant cannot be equal to 0. That's why we were saying previously that the determinant cannot be 0 for it to be invertible. Now let's have an example. Let's say you have matrix A as 1, 2, 3, 4. So the inverse of it will be 1 over 4 times 1 minus 2 times 3. And for here, it's pretty easy. You just exchange these two, so 4 and 1, and then these two will be negative. So minus 2, minus 3. Now we have 4 times 1 is 4. This is minus 6, so we have negative 2. So 1 over negative 2 times these. So it's the half of this one, so it's going to be negative 2, 1.5, 1, negative 0.5. So this is your inverse matrix.